This session, we will be seeing two of transformer applications, namely text classification, named entity recognition, question answering, summarization, translation or machine translation, and finally text generation. Now before moving into implementation part, we will be installing transformers library. In order to install transformers library, we will use pip command, pip install transformers, and we will run this block of code. Now you all know that transformers has a layered API that allows you or allows us to interact with the library at various levels of abstraction. So if you have not gone through this or if you haven't understood this, go through the first and second tutorial of this entire Hugging Face course. Now that our transformers library is installed, we will see one of the most important Hugging Face function, which is called as the pipeline function. Now this pipeline function, we can instantiate this pipeline by calling the pipeline function. In order to do that, we will import first the pipeline. So from transformers, import pipeline. So for the first use case, we will implement a small use case of text classification. In text classification, we will see sentiment analysis. Now to give you a brief about sentiment analysis, it can be with respect to any product, it can be with respect to any service, or it can be with respect to any XYZ item. The input text can be, my experience so far has been fantastic. So it means that the sentiment towards that particular item or product is positive. If a user says that the product is okay, I guess, then the sentiment towards that product is neutral. And if the user is saying that your support team is entirely useless, then the sentiment towards it is negative. It means that the customer is unhappy with that particular support team. Now in order to implement this sentiment analysis code, we will instantiate the pipeline. For example, let's say classifier, I'll take this variable name as classifier equal to pipeline, and in this pipeline I will put the task that I want to perform. So here the task that we want to perform is text classification. So I'll write this simply text classification. Now if I run this part of code, you can see that the first time we run this code, you will see few progress bars appear because this pipeline that we have called here and inside this we wrote text classification, it downloads all the model weights from the Hugging Face hub. If you do not know what Hugging Face hub is, I strongly recommend you to go to second tutorial of this session and go through the entire video. Now the second time you rerun this code, suppose if I want to rerun it again, then the library will notice that we have already downloaded the weights and it will use the cache version of that particular weights. So it will not download it again and again. Now by default, this text classification, it uses a model that designed for sentiment analysis. So by default, the model is sentiment analysis when we give it for text classification. Now, but it also supports multi-class and multi-label classification as well. So for now, let's get into this text classification or sentiment classification use case. Now, suppose if I am writing this text, or let's say reviews equal to, I will write two reviews. First review will be my experience so far has been fantastic. And the second review, I will write, let's say, your support team is completely useless. Okay. Now this will be my input to this classifier. Now in order to get the predictions from it, I will take a variable named as outputs and I will call this classifier, and in that classifier I will simply input this reviews variable. Okay, now let's run this part of code. And print this outputs. So here it is outputs. We can see that this first prediction corresponds to the first sentence that we wrote. So the first output for this, or the first sentiment output for this sentence, that is my experience so far has been fantastic, is positive, and it has also assigned a score, or we can say a probability of it being a positive. So the model is highly confident that the first sentence is positive. Similarly, we can see that the second sentence, the model predicted label as negative, and also we can see here that the score is 99.8%, almost touching 100%. So in both the predictions, the model is pretty confident that the first review is positive and the second review is negative. So this is a simple text classification application using pipeline function of Hugging Face transformers. Now let's see an example of named entity recognition with the help of transformers. So those who do not know what NER or named entity recognition is, so here in this image there is a paragraph, and in this paragraph the NER or NER model or named entity recognition model will extract person's names, location, organization name, etc., like date and so on. So all the important entities which is contained or which are contained in a particular paragraph or sentence, NER model will extract it. So this typical example is with respect to extracting location, person name, organization, etc. You can build your own custom NER model to extract, let's say, legal entities from a document, or intents in a particular message, and so on and so forth. The possibilities are endless. So in order to execute this NER code, first we will get a variable NER tagger, and we will use the same pipeline function. And in this, the first argument will be the task which we want to solve. So the task is NER. Simply I will run this. So as I said earlier, as it is my first time executing for this NER, it is downloading the weights of NER model. So for this, it is downloading this model. You can see here this model, DBMZ BERT large case fine-tuned Cornell 03 English. So what is this Cornell? What is this BERT large case? We will be seeing in depth in the coming session. The aim of today's session is to give you a tour of all the Hugging Face applications by using this pipeline function. So we are with 50% download, and to implement all this we are using Google Colab. If you want this code, I'll upload this entire code to my GitHub repository, which you can find in the description of this video. Now that our model weights, configuration, vocabulary, everything is downloaded, let's give this some text, like input text. So let's say my input text would be Mark Zuckerberg is one of the founders of Facebook, which is a company from the United States. Okay, so this is my sample input statement. Again, I will take the same variable outputs, and I will call NER tagger variable object, and then I'll simply input this text here. and I will print this outputs. Now you can see here, this is the output which is given by the model. So what it is outputting is, the first entity that is extracted is mark. Now mark is PER, it means person. Again the second entity is something called as Z, it is also person. The third entity is something double hashtag UK, don't misunderstand this word, but double hashtag UCK, and this is also some person. Now this double hashtags is because of the tokenization mechanism. In order to get rid of this double hashtag and in order to get a clean output, we just have to make a small modification when we make prediction. So here, instead of just inputting text, I'll give another parameter which is called as aggregation strategy, and I'll tell the model that the aggregation strategy has to be simple. Now again I will simply print the outputs. Now let's see what it gives. So here the output is clean, precise, crisp and simple. The entire thing Mark Zuckerberg is captured as person with a score of 95.3 or a probability of 95.3%, and then the Facebook is org, that is the organization, and United States is the LOC or the location. So in this way you can perform NER or named entity recognition with the help of transformers. But keep in mind that while predicting, you have to keep aggregation strategy simple for this kind of output, else you will get output of this type wherein the words will be tokenized. So there is something called as wordpiece tokenization and so on, that we will be studying in the next sessions. So now let's start with question answering. Here we give context as well as the question as an input to the machine. So here the context is nothing but a simple input paragraph. This paragraph consists of multiple sentences and is typically a huge paragraph or an entire document. And the question here is related to this input paragraph. So whatever there is in the input paragraph, we can ask any question related to that. So here the context was, the capital of Germany is the city-state of Berlin. It is the seat of the president of Germany, and ... it means the paragraph can be a long paragraph. And the question asked was, what is the capital of Germany? Now the model understands, or the system understands, this particular paragraph, and it will extract Berlin as an answer to this particular question automatically. Now let's implement this question answering by using Hugging Face transformers. Now we will take a variable, let's say question answering system equal to, again our favorite pipeline function. I will give here question, I have made a mistake here, pipeline question hyphen answering the task which I want to perform, and I'll run it. Okay. Now after downloading all the weights, vocabulary, etc., we can input the paragraph as well as the question related to that paragraph. So here, as you can see, it downloaded Distilbert base case distilled squad model. So the context, this context or the paragraph, so let's term it as paragraph. Paragraph is question answering. So I have just randomly copy pasted this particular list of statements from a blog. You can copy paste any paragraph of your own. So here the paragraph is as follows: question answering is a common NLP task, etc. So I will ask a question from this paragraph. So my question is, the question to the model is, which is a common NLP task? Now what the machine or what the model will attempt is, it will understand what the paragraph is all about, and it will try to fetch the answer to the asked question. So again, we will take our next favorite variables like outputs. We will use Hugging Face, this question answering system object, and I'll call this object. So here we have to input two arguments here. First is question, which is this question, and context, which is our paragraph. Now we will print this outputs. Let's see what it infers or what it predicts. So here the answer it predicted is question answering with a probability or with a score of 99.15 or 0.9915, and also it has given some offsets like this starts with 0, ends with 18, and so on. So this 0 and 18 is the start and end of character index or character offset from the input paragraph. So you can ask, or you can input any paragraph and you can ask any question from that paragraph itself, and it will try to give you a clear, precise answer with by understanding the entire paragraph depending upon how the model is trained. So this is with question answering. Now let's implement the next task of summarization. So here, if you don't understand what summarization is, I'll give you a brief idea about that. Given an entire huge document, the aim of summarization is to summarize the entire document into few important points. So by reading just few important points or by reading just summary, the reader will get an understanding about what the entire document is all about. So we will start with our summarization code. First, again, we will select our variable, that is summarizer, and we will call the pipeline function. The task here is summarization. So we will write here summarization. I'll run this block of code so that all the models and everything will get downloaded. So as you can see here, the model is getting downloaded. You can see here that the model downloaded is Distilbart CNN 126, this one. This is the default model that is getting downloaded. Now I have copy pasted this list of sentences which will represent a long document. This is all about deep learning stuff that I got from, I guess, one blog. So you can take any text of your own liking and you can paste that text here. To get better results, I would recommend that the text should contain more number of sentences and that paragraph should be huge enough so that the model can summarize it well, and you can see that okay, that this is actually the summary of that particular text document. Now again we will take outputs variable. We will call summarizer and input we will give it as text. Now it will take its sweet time to understand what the text is all about, and then it will generate the summary out of it. Let's see what it generates. So the processing is completed. I will simply print outputs here. So here, if we compare this text and the outputted summary text, we can see that the summary is a short and sweet text which represents the entire meaning of the input text. So this is with respect to summarization. Now the next task that we will accomplish with transformer is translation or machine translation. So in order to so for those who don't know what machine translation is, in simple terms, training a machine or training a system to translate a language in one form to another form. So it can be from English to French, or French to English, or English to Korean, or Korean to Japanese, or language 1 to language 2. So everything is done automatically with the help of a model or a machine or a system, or a trained system to be precise. So let's say machine translator or translator. Again we will call our favorite pipeline function. In that the task is, let's say I want to translate between English to German. So I'll give here translation source language, that is English, and then the German language, that is DE. Now if you are JT, okay, then I will write here text. Let's keep it simple for now. So hello, how are you? And then I will just print first, and then we will do predictions. So again we will call outputs equal to translator, and in this we will give input as text, and then we will print this output. Now as this was the first time that we have executed this block of code, it is again downloading machine translation model. So it is now downloading T5 bit or text to text based transformer model. So here we will print outputs. So this model has given the translation of hello, how are you as this translation. You can see here, this one. So in this case you can translate from one language to another language using transformers. The last application that we will be seeing for today is text generation. For text generation we will follow the same steps. Let's say my text generator equal to pipeline, and in this I will write here text generation as a task that I want to perform. Again if I run this, it will download the model, the default model. So in this case here you can see that it downloaded or defaulted to GPT-2 model, and it is now downloading GPT-2 model of about 548 MB. Let it download. It takes its own sweet time to download. So we can see here it has downloaded the entire model as well as vocabulary file and configuration files. Now how this text generator work is, we have to give an initial prompt for that particular model. So prompt would be, let's say I like machine learning and to solve different business problem statements. So this is the prompt that we will give the model, and with the help of this prompt it will try to generate statements which is associated with this prompt. So here we will take outputs equal to we will call text generator here. In this we will input the prompt as a message. Again it will take its own sweet time to generate output, and if we print this output, if we print this outputs, we will see the result that it has generated. So here it started like I like machine learning and to solve different business problem statements. So this is the prompt that we gave, and then it generated its own part, like, so this has already allowed me to analyze many of the business question statements where I could improve my solution and find the answer. This is the best part about the machine learning business. And so here we can see that this statement is cut in between. There are multiple different parameters in this text generator, so that if you want to generate, let's say 100 words or 200 words, n number of words you can specify in this text generator prompt. So all these parameters we will be seeing in the next sessions when we actually build all these applications right from scratch. So in the next session onwards, we will see how to build text classification, how to train a model of text classification from scratch, NER from scratch, question answering from scratch, summarization from scratch, translation from scratch, and finally text generation from scratch. So that's it guys for this video of the entire tour of transformer Hugging Face applications. Thank you guys.